Hi everyone. Thank you for attending and thank you to SAFE for allowing me to present. The title of my presentation is Eglinton Crosstown West Extension, Leveraging FME to Automate Data Conversions. My name is Raj Ubi. I am a GIS analyst at Arup Canada in the Toronto office. I started as an intern with the firm in January of 2021 and I've been here since. I completed my master's in geography with a specialization in geographic information systems. I've had the opportunity to continue learning, developing, and applying my skills at Arup. Before we jump into the presentation, here is a quick presentation breakdown. I will start with a project overview, followed by challenges and objectives. After that, I will describe the solution and results, focusing more on why we chose to take the approach that we did. I'll finish with a conclusion, and I'm happy to take questions after that. Arup is a global, integrated, and multidisciplinary firm with professionals working to tackle complex planning, infrastructure, and building design challenges. As of 2022, the firm is made up of 17,000 engineers, designers, and consultants, along with many other professionals, spanning across 33 countries in 89 offices. Dedicated to delivering value through expertise, global resourcing, and local delivery, Arup offers full services from concept through to completion. On the right are a few of the projects that Arup has been involved in over the years. This includes the Sydney Opera House in Australia, the Gherkin in the United Kingdom, and the Samuel de Champlain Bridge in Canada. Moving on to the project, Eglinton Crosstown West Extension, abbreviated as ECWE, is a 9.2-kilometer extension of the Eglinton Crosstown Light Rail Transit in Toronto, Ontario, Canada. There will be 4 new underground stations, 2 elevated stations, and 1 partially below-grade station, a 6.5-kilometer tunnel, and there are plans that are being explored to extend ECWE to the Pearson International Airport. Arup is a technical advisor to Metrolinx, who is the client on the project. Arup provides engineering design and technical advisory services to support procurement, coordination, and construction. The project is designed to have an approximate of 37,000 weekday corridor boardings with easy transfers to Up, Go, TTC, and MyWay services. Initial calculations suggest that it will cut time by about 14 minutes when traveling between Midtown Toronto and downtown Mississauga. With approximately 50,000 more people within walking distance to the light rail transit system upon completion, 31,000 more jobs will be accessible and 39,000 metric tons of annual CO2 will be reduced. ECWE is a massive project with multiple contracts and changing design elements over an extended period. Supporting a complex multidisciplinary design requires the use of digital tools to facilitate project management and collaboration. Arup Fuse was our digital tool of choice on this project. Fuse is a secured platform under a single URL where users can access, manipulate, or submit project information. It can be incorporated with and integrate project data from multiple software like Arup Atlas, which is a built-in full-featured web GIS portal, Power BI, ProjectWise, and FME. Fuse has been used on projects across the globe in a range of different business sectors, including highway, rail, energy, and aviation. For ECWE, Fuse is the single source of information for open source data, surveys collected on site, and CAD files developed by our design teams and then saved on ProjectWise. Here is a screen capture of Fuse. Along the top right of the platform are the different available modules. The current view is of the open data map. The layer list contains the different available layers, most of which are CAD files developed by our design team and then converted to GIS feature classes. Each feature class contains a pop-up with additional information, like a hyperlink to the respective ProjectWise location. Fuse consolidates multiple files into a single application, giving users the ability to easily view multiple design files across the project at the same time and within a single location. Another module we built for Fuse is the Model Tracker. This is a dashboard developed using Power BI designed to track how frequently CAD files are updated in ProjectWise and then published onto Fuse. It tracks files by discipline, the last date modified, and automation status, giving project managers the ability to view how frequently designs are updated on a project. Fuse works best when data supply to the platform is up to date. At the beginning of this project, we manually downloaded CAD files from ProjectWise, converted them to GIS feature classes using individual FME workbenches, and then published those GIS feature classes onto Fuse using ArcGIS Pro. This process was repeated for each discipline and every time a CAD file was updated. As you can imagine, it took up a lot of time and resourcing. Since design changes are frequent on this project, it made it difficult to keep data inputs on Fuse up to date, and managing multiple types of data did become overwhelming. There was also no way to check if CAD files had met project data standards before converting and publishing files to Fuse. This meant the conversion process had to be done multiple times if CAD files were not developed according to standards, and that led to multiple human errors, like downloading the wrong file from ProjectWise, converting the wrong levels, and then incorrectly naming layers. When I started at Arup, I was asked to manually update Fuse, but I thought, what if we could automate this entire process? So I asked my manager if it could be done, and she agreed. I had to create an automation that could check if CAD files had been recently updated on ProjectWise, then convert those CAD files to GIS feature classes and upload them onto Fuse, and then finally flag any CAD files that did not follow project data standards. The automation had to be applied across multiple files received from multiple disciplines, and it also had to work with multiple platforms like ProjectWise and Fuse. So I ended up making an automation workflow using FME Desktop and FME Server that could accomplish the task. The first workbench is called the Download Data from ProjectWise trigger. It runs on an 8-hour schedule in FME Server. Each time it runs, it scans through all discipline folders in ProjectWise and then downloads any CAD files that were updated on the day of the run. Next, depending on the files that are downloaded, it will use an email trigger to begin the CAD to GIS conversion process through an FME automation for that respective file. The conversion workbenches also sit within FME Server, and one workbench exists for each discipline. For example, if the station's CAD file is updated today, it will be downloaded from ProjectWise and trigger the architecture workbench to begin converting the station's CAD file to a GIS feature class. Once the conversion is complete, the GIS feature class is published onto Fuse, and an email confirmation is sent to me. The conversion workbench also checks to see if CAD files follow project standards. If not, the workbench stops and I receive an email notification. At that time, I get in touch with the designer and see if we can update the CAD file to meet the project standards before we publish onto Fuse. So through FME Desktop and FME Server, we were able to accomplish all of the automation tasks that were set out at the beginning of this task. We used schedules to download CAD files recently updated on ProjectWise. We used automations to trigger the conversion of CAD files to GIS feature classes. And then each conversion workbench contained an email trigger to notify me if a CAD file did not follow project standards. The FME automation workflow has been successfully running for about a year, and here are some of the statistics that I was able to put together. We have saved about 60,000 Canadian dollars since implementation. This is equivalent to about the salary of one full-time employee in Canada. 101 CAD files are automatically downloaded through the FME automation workflow, which takes about 8 minutes on average to run. Based on the conversion workbench that contains the most CAD files, it takes about 1 hour to convert all CAD files developed by a discipline to GIS feature classes and then upload those onto Fuse. Through the FME automation workflow, Up-to-date design information is always available to view, analyze, and monitor the progress of the project on Fuse. This improves data management and information tracking, helps enforce data standards, and eliminates human data errors. Since design information is up to date, the project team, client, and stakeholders can be confident that the information viewed on Fuse is accurate and reliable. This increases collaboration across all members of the project, making Fuse the go-to application to convey information during project meetings, to notify stakeholders and clients of any design changes and updates, and to be used to review and quality check information by project management teams. Finally, the FME automation workflow simplified an otherwise ad hoc process that required many softwares and multiple manual interventions. This saved time, resourcing, and significantly increased productivity. Now, there were roadblocks during the development of this workflow. The biggest lesson I took from this entire process is that communication with the design team is very important. Since CAD files are developed by the design team, I had to set up meetings with each and every discipline lead along with the designers to understand which files and levels needed to be converted from CAD to GIS. To ensure that the workbenches functioned correctly, I also had to make sure that file and level names were not changed. Since the project follows naming standards, this was not too hard to implement. However, I did agree on data standards for each file. To make sure that the FME automation workflow runs smoothly, I highly encourage data standards like the file name, level names, geometry, and data types to be written out, agreed upon, and followed by both the CAD designers along with the GIS analysts before beginning any kind of automation. This is going to save you a lot of headaches and confusion down the line. Any changes to these data standards should also be communicated as soon as possible by both parties. So in conclusion, through FME Desktop and FME Server, I was able to automate an ETL process to accurately maintain and upkeep project data. CAD files on Fuse are constantly up to date, despite frequent design changes to a project that contains 4 different contracts. As a result, we've been able to save a significant amount of time and resourcing. Finally, the FME automation workflow has helped improve the communication and project management of information across multiple disciplines, ultimately increasing collaboration within a multidisciplinary design team. In the near future, Arup is updating FME Desktop and FME Server to the 2021 cloud-based environment. This should significantly improve processing speeds and capabilities. I also plan to extract additional metadata from CAD files like the designer's name for more efficient tracking. We are also planning to use the FME automation workflow on upcoming and future projects. I think with FME, the opportunities are endless, and I am hoping to integrate this amazing technology in future initiatives. I'm really looking forward to it, and I know what it will do is going to be great. So thank you so much for listening, and thank you to Safe Software and your amazing team for letting me present my work and for giving me the opportunity to, come along during this virtual event. Thank you so much.